do you feel about the Chem 151 exam?
I did terrible on that exam. I should have started studying way sooner.
Oh my gosh, me too. I did so bad. Oh my gosh. Someone's asking for signatures. Do not make eye contact.
Hey, do you guys have a minute? I have this petition that I want to talk to you about. It's in regard to cleaning up the ocean.
Why is it so important?
Oh, cleaning up the ocean? Well, first of all, our oceans are a really big part of our ecosystems. They produce about half all the world's oxygen. They absorb about 1/3 of our carbon dioxide emissions. And they also have lots of biodiversity, which just generally is great for the planet. And yet we continue just to pollute and damage them. So I think this petition would be a great way if you guys can contribute, and we can talk about all the different techniques that we use for cleaning up our oceans.
Okay.
Plastic pollution is a major issue in the ocean because most plastics are made of long polymer chains held together by strong covalent bonds. These bonds make plastics durable and resistant to natural breakdown, which is why materials like PET, polyethylene terephthalate, can persist in the environment for hundreds of years. Enzyme-based degradation offers a more targeted solution. Certain enzymes such as PETase are capable of recognizing and binding specifically to PET plastics. PET contains repeating ester linkages in its backbone. These ester bonds are chemically vulnerable to hydrolysis, a reaction where water breaks a covalent bond. PETase catalyzes the hydrolysis reaction and the long polymer chains are cleaved. The plastic is converted into smaller molecules, primarily terephthalic acid and ethylene glycol. This breakdown is important because it transforms persistent plastic waste into soluble, manageable chemical components. Once recovered, they can be purified and reused as raw materials for manufacturing new PET products. In addition to enzyme hydrolysis, photocatalytic degradation is another promising method for breaking down plastic waste. Materials like titanium dioxide act as light-activated catalysts. When exposed to UV light, electrons in titanium dioxide become excited and generate reactive oxygen species, such as hydroxyl radicals. These radicals are highly reactive and attack the carbon backbone of plastic polymers, weakening and fragmenting the long chains. Plastics are converted into smaller, more manageable pieces. This makes them easier to remove through filtration or further chemical treatment. Overall, enzyme-based degradation and photocatalysis represent chemical strategies that break down plastics at the molecular level.
Hey, this is Professor Hernandez, and I'm here to present you with two great ideas for ocean cleanup. The first one is called ultrasound clustering. This idea works by using acoustic radiation force to push particles towards specific regions within the wave field. Then, intense vibration and motion causes the particles to collide with each other. This leads to the formation of larger agglomerates that can be easily separated from the medium through processes like sedimentation or filtration. Then we have a graph here that shows how it works. First, we have the microplastic solution. Then we turn on the ultrasound device for the reunion and accumulation, and results in effective removal of microplastics. The second cleanup idea is biodegradable flocculants. It is another great way to clean up the ocean, and it works by neutralizing the charges of suspended particles that cause them to repel each other so that these can bind together and form flocks. Flocks are larger and denser, which make them easier to remove. Removal processes also include sedimentation, filtration, and flotation. Then here's an image that shows how it works. We have the industrial wastewater, then we add the coagulant, and as it is treated, we add the flocculant, which results in destabilized wastewater particles. And once we treat this water, it just goes on by itself and results in wastewater sludge, which is bad for the environment. Next, we have a combined application. By combining these two methods, it may lead to a highly efficient and sustainable way to remove microplastics. Ultrasound may be used as a preconditioning step to induce collisions and flock formation, while biodegradable flocculants can be added to make even larger flocks. This would result in significantly less chemical sludge being produced and way less residual synthetic biopolymers.
I'm Parker.
And I'm Kiana, and we're going to talk about different ways that we can clean up chemical contamination and pollution in the oceans.
There are lots of different ways our consumer products can contaminate oceans, and oil spills are a huge issue.
Oil spills are a very common way our oceans are polluted, and they can happen anywhere oil is transported, drilled, or used. The National Oceanic Atmospheric Administration has reported over 150 oil and chemical spills every year in U.S. waters. A common method to clean up these oil spills is to use chemical dispersants. Chemical dispersants are agents similar to soap and detergents that are directly applied to oil spills in oceans. Chemical dispersants work because they have surfactants, which contain a hydrophobic part that binds to oil and a hydrophilic part that binds to ocean water. Once bound, the oil and water are separated, and with water movement like waves, the oil is broken up into smaller droplets that disperse into water column. Once dispersed, the oil droplets are degraded by natural systems like bacteria.
Many consumer products also contaminate our oceans, ranging from cosmetic and personal care products like makeup, soaps, and sunscreens to detergents, cleaning products, and pharmaceuticals. Remember those surfactants that Kiana was talking about? Well, most of those compounds include surfactants. There are three main ways to clean up chemical contaminants like surfactants: physical, biological, and advanced oxidation processes. Physical absorption methods like advanced carbon and clay trap surfactants, but don't actually destroy them. Bacteria can be used to break down some surfactants biologically. For compounds which can not be broken down biologically, advanced oxidation is required, which uses UV light and hydrogen peroxide, creating powerful hydroxyl radicals that destroy pollutants. These techniques, however, are very energy intensive and costly.
And while chemical dispersants are a good way to remove oil slicks from ocean waters, they also have environmental impacts that raise concerns. Once the oil droplets are dispersed into the water column, it can expose marine life to these toxic dispersant chemicals in oil. For example, a popular chemical dispersant, Corexit, has been widely used for big oil spills, but researchers have questioned how safe it is for marine organisms. Researchers have been altering surfactants in order to make them more biodegradable and significantly less toxic to marine life. But cleanup can only do so much, which is why prevention and product design should be the main goal.
Yes, well, there are many ways to clean up chemical contaminations in oceans. We wouldn't have to be cleaning them up if they didn't get into oceans in the first place. There are lots of alternatives and prevention methods to avoid contamination. Using biodegradable surfactants that can be broken down by microorganisms before reaching the oceans stops detergents from harming ocean life. And we can reformulate cosmetic and personal care products using molecules that can be degraded during wastewater treatment.
After watching those videos, do you think you'd want to sign a petition?
Sure.